Hey everybody, welcome to Multiplying and Dividing Rational Expressions, section 9.4. So in today's section we're going to continue with those rational functions we've been working with, and when I say rational I mean it can be written in fraction form, but today we're going to be simplifying them, and we're going to be using lots of fractions. So to start off with, let's do some review of working with fractions. So review. If I'm multiplying, multiply straight across. 3 times 2 is 6. 4 times 5 is 20, and then reduce. Now a technique that we're going to be using today is, I call it cross canceling, not cross multiplying, but cross canceling. And what I mean is, instead of doing this, if you can see on top and bottom that something can divide out and cancel, you can do that before multiplying. So here I know that 2 divides into 4, and that would reduce to 1, and that would reduce to 2, and so now on top 3 times 1 is 3, on bottom 2 times 5 is 10. I'll talk more about that as we go along. Dividing, remember, when you divide fractions, first fraction stays the same, second fraction turns to the reciprocal, and you multiply. And now let's employ this cross-canceling thing I was talking about. So first I see 3 and 3, and it has to be one thing on top and one thing on bottom, because when I'm multiplying fractions, they're all together anyways because they all multiply together. So it's kind of like I'm pulling out a common factor. So I got a common 3 on top. That simplifies to be 1 when I divide by 3. Divide this by 3 is 1. Okay? And then I can see 8 and 4 both can be divided by 4. So divide by 4 is 2. Divide by 4 is 1. So now on top, 2 times 1 is 2. On bottom, 1 times 1 is 1. 1, or just 2 is my answer. Let's try the same strategy with this next one. So think in your mind, what on top and bottom has a common factor that can be pulled out? I immediately notice 5 and 10 have a common factor of 5. So divide by 5 is 1, divide by 5 is 2. Alright, what else has a common factor? Let's see here. 4 and 16 have a common factor of 4. So divide by 4 is 1, divide by 4 is 4. 1 times 1 on top, 2 times 4 on bottom. If you got more than one thing, like right now, just the divide by part is flipped. So here, that would flip to be 7, 6. This part just stays normal though, because it is multiplied, not divide right there. Alright, now I want you to try for a second and see if you can cross cancel anything before multiplying this through. Alright, and then let me tell you something. If I divide the top and bottom by 3 here, I have used the 3 already. I can't divide by 3 again. So only one of the 3's gets canceled out, not both of them. Here I divide by 7. So on top I've got 3. On bottom, 5 times 2 is 10, times 2 is 20. Alright, let's talk about what it's going to look like when we have simplified form. So simplified form for what we're doing today is if the numerator and denominator have no common factors. If the numerator and denominator have no common factors. So notice what I was doing earlier in the warm-up. I was trying to take out what could be divided in top and bottom. That's called a factor when you divide it off. And one quick comment I want to tell you about, if I have things like this multiplied by something, very different situation than if I have things like this added. If you have it multiplied, I can pretend like the c is a common factor and divide it out, and that would be equal to a over b. If I have a plus sign though, it can't be simplified. This is very, very key. I would say number one mistake I see every year is students forget that if it's a plus sign, you can't cancel it. Now let me show you why, okay? Let me show you why. Let's say that a and b are 2 and 4, or no, 2 and 3, let's say. Okay, so let's say that a and b are 2 and 3. C is going to be 4, let's say. So the question is, if I was going to multiply this straight across, I'd have 2 times 4, which is 8, 3 times 4, which is 12. That, when I simplify, that is equal to 2/3. Is that the same answer I would get if I canceled before multiplying. So if I said, okay, 4 and 4 have a common factor of 4, I can divide those off first. Is that the same thing as what I started with? Yes. Okay, so check. It works to cancel if you're multiplying. But notice this guy, 2 plus 4 is 6, 3 plus 4 is 7. That's 6/7. That's very clearly not equal to 2/3 if I try to just cancel those out. So it doesn't work. It's not equivalent. You can't cancel if there's plus signs. Come back and look at that whenever needed, because that is really, really important. So if it's multiply, you can cancel. If it's plus, you can't cancel. All right. To start off with, you're going to be given some things that look very similar to what we did in Chapter 7. So actually, to start off with, this is not really new material. What we're going to do is we're going to simplify our variables and simplify our numbers. And if you prefer, some students like to multiply the variables together first just to figure out how many are on top and how many are on bottom. Here's what I mean. I got x squared times x cubed on top. Remember that when I have x squared times x cubed, you add the exponent. So that becomes x to the 5th. And then on top, I've got y times y squared. So it's really like y to the 1st, so that's y cubed. On bottom, I've got plain x all by himself, and then y cubed times y, so y to the 4th. All right, so that's my variables. Let's look at our numbers. If you want to employ the cross-canceling thing, I'm looking for a common factor. So is there anything in common on top and on bottom that I can pull out? And it has to be one on top, one on bottom to pull something out. I immediately see, okay, I got a 5 and a 10. Those can be divided by 5. So divide by 5, divide by 5. And then how about the 6 and 2? I can divide by 2. So divide by 2 is 3. Divide by 2 is 1. So now 1 times 3 is 3. 1 times 2 is 2. The only thing I need to do to finish this problem is to figure out how these x's and y's simplify. And I hope you remember from Chapter 7 that when I have on top and on bottom, you subtract them. So 5 subtract 1 is x to the 4th on top. 4 subtract 3 would be y to the 1st, but there's more y's on bottom, so it stays on bottom. Go ahead and pause the video and try B on your own. All right, you should have 14 over 39 y cubed for your answer. Last but not least, let's look at C. So I specifically put this problem in here because I wanted you to, again, remember, I cannot cancel if there's a plus sign. So I cannot immediately cancel this. But here's what I could do, and this is going to lead into what we're doing with example 2. If I can rewrite this as something multiplied by something, something multiplied by something, then I can cancel. So here's what I mean. X squared, I could rewrite that so it's x times x. And then on top, I can actually factor this like we hopefully have been working on. I can factor an x out of there, so I've got x times x plus 5. And now, because it has a multiply, now you can cancel that x and that x. And so my final answer is x plus 5 over x. And again, you can't cancel if there's a plus sign. So now, we're going to be multiplying and dividing with factoring, and most of them are going to be the 2 parentheses type, but there are going to be some more greatest common factoring problems. And I want to tell you something. If you are super good at factoring, you may secretly enjoy this. So if you're going along here and you're like, wow, this is actually kind of fun, you can tell me tomorrow in class, because I secretly enjoy this as well. I think it's pretty cool. All right, here's why. I'm good at factoring. I've had lots of practice over the years. What we're going to do is we're going to factor the top and factor the bottom using the strategies that we have been working on all week. Remember that if I have just 2 pieces, it's usually that special difference of squares situation. And my goal here is to rewrite all these so it's something times something. Because remember, if it's something times something, that's when you can cancel. And now I'm going to factor the bottom to be x plus 2x minus 2. And the top, I'm looking for 2 things that multiply to be negative 12, add to be negative 4. So I'm thinking x minus 6, x plus 2. And now this seems a little weird, but this entire piece is being multiplied by this entire other piece. So as long as it's a whole chunk, it is legal for me to cancel out the whole chunk because it has that parentheses. It counts as like a number because I could put something in for x and turn it into a single number. You know what I mean? And so your final answer is x minus 6, x minus 2. And we are done. There's no common factors. And remember, I can't cancel it any further because it's just a plus and minus sign. So basically every single time, this is what it's going to be similar to. So let's think about factoring this next one. Think in your mind, okay, what multiplies to be negative 6 but adds to be negative 5? I'm thinking x minus 6, x plus 1. And you know what? I'll give you a secret. These are meant to cancel. So if I have a x plus 1 or a x minus 6 on top, it's very likely at least one of those are on bottom. In this situation, it's another difference of squares 1. So x minus 1, x plus 1. And then whatever parentheses is in common on top and bottom, that counts as your common factor. And so x minus 6 over x minus 1 is my final answer for example B. Moving on to C, I want to show you what it looks like when you have a situation where you're factoring out a greatest common factor. And notice each one of these blobs we're going to have to factor. This one down here is the only one we don't have to deal with. And another thing I want to tell you is sometimes when I'm doing these problems, I don't rewrite it on the side. I like to just write it above it. That kind of makes it a little faster. So let me show you what I mean. Let's do this blob down here first because I think that looks easy. In my mind, I'm like, okay, what multiplies to negative 3 but adds to be 2? What multiplies to negative 3 but adds to be 2? I'm thinking 3 and negative 1. So what I do is I sometimes just write it down there and then cancel that out. You don't have to do that, but it's a shortcut I like to use. Alright, I'm going to do this blob in the upper right hand corner next. I now want two things that multiply to negative 6 but add to be a 1x. And here is where, if you are someone who still struggles with factoring, the only reason you might be lost right now is you don't know how to factor. For those of you who are good at factoring, I'm probably going way too slow for you. Alright, again, the lower right hand blob doesn't have to be changed. So let's look in the upper left. It's not the two parentheses method because x is not something squared. If it has a subtract sign, both of those have to be squared to follow that special pattern we used in A and B. So then next I want to think, is there a common factor I can pull out? And I think there is, and it is 4x. So if I pull out a 4x out of both of these, 4x divided by 4x is 1, negative 4x squared divided by 4x is negative x. Alright, now let's cancel what we can. I see a x plus 3 on top, x plus 3 on top. I see a 4x on top and a 4x on top. And then you might be wondering about this guy. Now I want to tell you that as is, these are not the same because this one has a negative x and this one has a positive x. There is something we can do about that though. Let me write down what our answer is at this time before moving on. So right now on top I got 1 minus x, x minus 2. On bottom I have x minus 1. Now here's the deal. This seems a little weird, but right now these parentheses don't cancel. I actually can factor out a negative 1 in order to make these match. Here's what I mean. When I factor out a negative 1, 1 divided by negative 1 is negative 1. Negative x divided by negative 1 is positive x. So what I have essentially done is now, if these are in a different order, but negative 1 plus x is the same thing as x minus 1, right? Agree with me? Same thing? Yes? Alright, so now I can cancel them because they're the same. And here's my final answer, negative 1 times x minus 2, or negative x plus 2. Thanks for listening, and please join me for 9.4 Part 2. Hey, welcome to 9.4 Part 2. First question, are you having fun yet? Alright, so let's have more fun. When I look at this now, I've got 3 different blobs again that need to be factored, and notice it's getting harder. Now I got that 3 in front of the x squared. So think about the factoring practice we've been doing, and in my mind I'm thinking, okay, in order to make it be 3x, I got to have 3x and x. So same thing down here. Let's do this first one up here first. So I still want two things that multiply to be a 1. And maybe I'm going to do some guess and check action. Actually, the only thing that multiplies to be 1 is -1, -1. Alright, so check it really quick. Outers, -3x, inners, -1. Okay, check, it works. And now remember again, usually at least one of these parentheses is going to match. So, but on the other hand, that has to be a -1. So to multiply to be a -1, it could be 1 and -1. And let me check it. Again, I'm just guessing and checking. Right now it's going to be -3x outers plus 1x inners. That's -2. That's what we wanted. So yay, first guess for both of those. This one down here doesn't need to be factored. This one up here, I'm going to just go ahead and tell you guys, you're not going to have to factor x cubed with a special x sum and difference of cubed rule, so don't worry about that. If it's like this, then that means it's going to be one of those ones where you factor out a common factor. Now, I'm going to pull out a 3x. 3x divided by 3x is 1. -27x cubed divided by 3 is 9x squared. So I'm going to cancel out what I can, and then I want to show you something. So, alright, I can cancel out 3x and 3x. I can cancel out x minus 1 and x minus 1. So right now I am left with 1 minus 9x squared and 3x minus 1 on top, and on bottom 3x plus 1. So now every single time when you get to some of these more advanced problems, you're going to have to look for those special patterns. And in this situation, both of these numbers here are squares. 1 is 1 squared, that's 3x squared. So that means it's a difference of squares situation, and I can factor that into 1 plus 3x, 1 minus 3x. These other two parentheses I haven't touched. Now, again, it's not written in the same order, but one of these is going to cancel with the bottom one. Look it through here. Alright, it's the one on the left, because both of those are positive, both of these are positive. So 1 plus 3x is the same thing as 3x plus 1. Alright, final answer, 1 minus 3x times 3x minus 1. When you're finished writing that down, flip to the back. On the back side, we're going to talk about dividing. And the only difference with dividing is, remember, we have to flip the second fraction, and the first fraction does not flip. So usually when I'm doing these, I do like to rewrite it in order to make sure that I get the flip in. So, okay, let me show you what I mean. On top here, 5x stays 5x. On bottom, I could factor out a 3. Then I'm going to change this to multiply, so I'm going to take the reciprocal of these. So this is actually going to be on the bottom. So x squared minus 2x. I can pull out a x, and I get x minus 2 for my remainder. So again, whatever was on top went to the bottom, and now whatever was on bottom goes on top, because I flipped it, because I was dividing. Alright, two things that multiply to be 8, but add to be -6. I am thinking -4 and -2. Last but not least, I get to start canceling. Remember, you can pretend like it's one big fraction bar if it's multiplying. So, and all of these are all multiplied together, even though they're spaced out. So x minus 4 and x minus 4, x minus 2 and x minus 2, and actually x and x. My final answer then is 5/3 for that one. For part B, I'm trying to trick you here by putting something that isn't in fraction form, but you can just rewrite it so it's that over 1. So when I flip it, it's 1 over whatever I have here, and let's just do that right away since I'm there. So this one, it only has 2 pieces, so it's not a trinomial, so I can't do the 2 parentheses. I'm going to pull out what's in common. So I look at this, I can pull out an x. 2x squared divided by x is 2x. 3x divided by x is 3. X times 2x plus 3 is the factored form for that one then. And then over here, let's go for it. That doesn't change, 6x squared. Alright, and then here, this is annoying. I'm going to have to do some guess and check action. So it could be x and 6, or it could be 2x and 3x. So x and 6x or 2x and 3x. Now let me tell you, here's where you can be strategic. Remember, your book is trying to make it so things cancel. So if I see this right here already has a 2x right there, go through and guess that first, because it's very likely that that's the one that they want to have cancel at the bottom. And also, on that note, when I'm guessing here then, let's try to make it so it matches 2x plus 3, and then if that's the case, that would have to be a -1, because I want two things that multiply to be -3. And let's just check it really quick, and this is me on the side doing guess and check action right now. Alright, oh wait, oh yeah, okay, and it works. 9x plus -2 is 7x for my outers plus inners. Okay, so this top part factored into 2x plus 3, 3x minus 1. Nice. Let's cancel. 2x plus 3, 2x plus 3, and that's it this time. On top then I got 3x minus 1. On bottom I can multiply these guys together. So I get 6x cubed. And it might look like these are going to cancel, but remember, they can't, because it has a minus sign. Can't cancel if it's a plus or minus sign. Last but not least, we're going to do the compound problems where I got 3 different things being divided, multiplied, and so on. First, remember, if you don't have a number on bottom, it's really like that thing over 1. And then remember that this part here is going to flip. I'm going to go ahead and rewrite these so it looks a little nicer. So I have got x, and you can add parentheses if there wasn't a parentheses to start off with. So on top right now, I've got x, 3x minus 5 is also on top from this part of it. Here, remember, flip it, so the x plus 5 goes to the top. And this part right here, 9x squared minus 25, I'm thinking difference of squares, so I'm thinking 3x plus 5, 3x minus 5. Cancel, cancel. X over 3x plus 5 is our final answer. Now I'm just going to throw it out there again. If you understand factoring, you're probably with me. If you don't understand factoring, you might be feeling really lost right now. So it's very, very important that you ask for lots of help in class or come before after school. Make sure you understand this. Let's do D. So I have 2x plus 3 over 1. So 2x plus 3 is on top. I hope you don't mind that I'm combining them all into a single fraction. If that's throwing you off, let me do it the other way this time but it doesn't matter, it's the same thing either way. So that one, nothing can be factored. Here, this middle one, again, flip it because it's divided by that. So only the one that's divided flipped. Even though this is afterwards, it still stays the same. So x minus 2 goes to the top, and the 4x squared minus 9, I'm going to again do difference of squares, so that ends up being 2x plus 3, 2x minus 3. And that one had nothing on bottom. Cancel, 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 cancel. X over 2x minus 3 is the final answer. Additional practice problems we're going to do in class. So if you're going to be in class tomorrow, just save them. If you're not going to be in class tomorrow, do them now. Thanks for listening, and I hope you had fun.